Hello, and welcome to Intermediate Macroeconomics. Today, we're going to be covering our math review. My name is Sergio Campo Diaz, and I'm the instructor for this course. Let's get onto it. In our math review, we're going to be covering three main topics. The first one is we want to talk generally about optimization. Optimization is critical for most of the things we do in economics because it's the way we're going to capture how agents in the economy make decisions. So today we're going to be talking about why do we optimize and also the concept of trade-offs, which is a concept that's key in understanding the result of optimization problems. Then we're going to focus on constraint optimization problems. We're going to focus on two types of solution methods, eliminating constraints and the Lagrangian method. Constraint optimization problems are ubiquitous in our models because most problems agents face in the economy are subject to a certain type of constraint. We're going to be clear about that later. And then finally, we're going to be covering some functional forms that we're going to be revisiting as we go and work through problems in the course. Okay, so off to our first topic, optimization. And I want to take a step back, and before we actually solve any optimization problems, think a little bit about why do we optimize? Why do we need to talk about this in economics? Turns out optimization is how we capture decision making. And decision making is important because economics is all about how people make decisions. It is all about the way they make them and the consequences of those decisions. Be it how somebody in a firm is choosing how many people to hire, the price they want to charge for the goods they sell, how much labor somebody wants to offer, whether they want to offer labor at all or not, perhaps they want to stay home. How much consumption or savings does somebody want to have? And then macroeconomics, the topic of this course, is all about the aggregate consequences of individual decisions. And so before we turn to those aggregate consequences, we need to have a way of understanding, again, how individuals make those decisions. And the mathematical way in which we capture decision making is with derivatives. And so every time we think about agents making decisions, we are actually thinking about mathematically about agents taking derivatives. And so when we take derivatives in our problems, we're really simulating the decision-making process of individuals. Okay, so why derivatives? Well, let me again be very abstract and think about a very generic optimization problem. And they always take the form of choosing the value of a variable. Here the variable is x, and we're going to be signifying that by this subscript on the max. These are the variables we're choosing to maximize some objective function, in this case f. You might think of choosing consumption to maximize utility, choosing labor to maximize profits. Now we know from calculus that the maximum of a function is a critical point of that function. And a critical point is a point x star such that the derivative of the function at that point x star is equal to 0. And that's just the definition that you've covered before in your calculus classes. Now, critical points are going to be important because the value of the function does not improve by moving x in any direction. That's going to be the interpretation we're going to give to this type of point. The derivative is how much the value of the function changes if we try to move x a little bit in any direction. Here, we know that the value of the function will not improve. It will just stay the same. So we cannot improve on it. That means we've reached a maximum. Okay? Now, it's very important to go through this intuition because it is what's going to cement the fact that when we do these derivatives, when we take these derivatives, we are maximizing, but we're also modeling decision making. And we're going to be going again and again through this. If the derivative at some point is, say, positive, then we could increase the value of f by increasing x a little bit above x star. So x star is not really optimal. Now, this not only gives you the fact that x star is not optimal, as we will see, it also gives you what the agent should be doing in order to improve the value of f. And that's exactly what we want to go at. So why do we take derivatives? Because derivatives do a good job at capturing how to make decisions. They basically give us a recipe. You first find out what you want to optimize, say profits or utility. This is going to be f, okay? So that's the function you want to maximize. Then you find out what you're choosing. If you're maximizing profits, you might be choosing labor demand. If you're maximizing utility, you might be choosing consumption. And this is going to be what we're going to call x. And then you can take the derivative of your objective function f with respect to your choice variable x, say the derivative of utility with respect to consumption. And two things can happen. If the derivative is positive, that means that increasing x, increasing consumption, also increases utility. And so the recipe, the conclusion is clear. You keep increasing x because that keeps increasing your utility up until you find a critical point, up until increasing x further will not increase utility further, and then you're done. If on the other hand the derivative is negative, that means that increasing x, in this example, increasing consumption, will actually decrease your utility. Well, we don't want that, so we're going to backtrack. We're going to decrease x until you find a critical point. And so this way of thinking, it's really what's behind the fact that we use derivatives. We want to model, we want to capture. Modeling is just a way of capturing reality. We're going to model how people make decisions by the fact that they are taking derivatives. And so we're going to take derivatives as well. So why don't we, why take derivatives here? Well, we want to model that fact that we don't always bother going through all those steps. Most times it's just going to be easier to think abstractly and just solve directly for that critical point. We don't need to go through the steps of like, I'm going to take a point, I'm going to check my derivative, then I'm going to go up or I'm going to go down depending on what derivative is. You might just want to take the derivative and find the critical point directly. That's what we're going to use mostly. But the steps of optimization should always be on the back of our minds. That's because that's first what we're actually doing when we take derivatives and equate to zero. And second, because derivatives are useful in general, but they are not all the time what you need. And we're going to go through examples in which that doesn't happen. And then finally, I want to address, why should you think abstractly? Why am I insisting on talking abstractly about f and x? Why not just give you an example and be done with it? Well, thinking abstractly is harder. It's definitely less clear than if I give you examples. But at this point, you've seen those examples in other courses. And turns out, thinking abstractly has two very big benefits that I want you to capitalize on. I want you to achieve this during this course. The first one is thinking abstractly helps you learn the broader lessons from class material. The point of the class is not that you learn how to maximize utility subject to a budget constraint, or that optimal consumption is equal to 5 or it's equal to 10. That's really not the point. The point here is for you to learn general lessons about how to think about optimally taken decisions. How should you think about the way shocks affect the economy by thinking about the decision-making process of different agents. And thinking abstractly, it's going to help you draw those conclusions about general issues from the specific problems we're going to solve. And so that's why I'm going to be focusing a lot on interpretation. The second thing, and that's probably a little bit more concrete, thinking abstractly is also going to help you understand faster new material, both in this class and in the other courses you're taking now and the courses you're going to take in the future. By thinking abstractly, you can see how different topics that you're covering are actually using the same ideas just in different ways. So the way we write things might look a little bit different, but the general way in which we're thinking, the general tools that we're using to solve those problems are actually the same over and over again. So I also hope that through this course, you learn these general tools that are going to be useful for you going forward. With this, we finish this lesson. In our next video, we're going to be covering the concept of trade-offs and how they are really embedded in the concept of derivatives. And it's going to be something that's going to be popping up again and again in the course. Thank you.